Hello, everyone. You are welcome to today's session. And today we are going to be talking about generative AI opportunities and implications for engineers. We'll be exploring what opportunities and what are the implications that engineers would have to encounter when working with generative AI. And this is a presentation I made for the Nigerian Society of Engineers Minna branch. So artificial intelligence generally means a technique that you can adopt to replicate human intelligence in machines or uh, copy what humans do and give that ability to machines and computers. Now, AI has various domains and various aspects. One of the aspects of AI is expert systems, like your fuzzy logic systems, where you define the input and the output, and then the rules that guide the interaction between the two or map the inputs to the outputs. You also have optimization, where you define a cost function or an objective function within a problem space and you try to find a solution to that problem or cost function, which usually represents the minima of the function. So you're trying to minimize that objective function. Now, a common area of artificial intelligence is machine learning, where it's used interchangeably with AI generally, but it's not really the same. Machine learning is a subset of AI. And that involves the systems or the computers learning from experience, learning from data that you've acquired that represents a trend over time. So this data can be numerical, it could be images, it could be text. And an aspect of that machine learning is deep learning, where if you look at images, for instance, you have them in 2 dimensions, which could be complex for standard machine learning algorithms to analyze. So deep learning provides an opportunity where you can analyze spatial data or 2-dimensional data. And it has a large architecture, a lot of hidden layers, and that's why it's referred to as deep learning or deep neural networks. Now, an aspect of that is generative AI. Now, generative AI mainly focuses on the creation of new and original content. So unlike your conventional AI models that you already have the data and you want to do classification or prediction, or you have inputs and you're trying to map them to outputs depending on certain rules, Gen AI mostly focuses on generating new information, maybe data, images, text, or even scenarios. Now you have a lot of applications. You can use it in image generation to generate images like DALL-E, Meta AI, Canva AI can do. You can use it in software and coding or generation of text and summarization like what ChatGPT, Gemini, and Meta can do. You can use it for chatbot development and improvement. You can use it to develop sounds like in SoundRaw and Eva. And you can use that together with the video technologies to develop fake technologies. So there are various types of Gen AI models. You have the transformers, you have the generative adversarial networks, the GANs, you have the variational autoencoders, and many more. So these are just different types of models or various techniques that you can use to build Gen AI models. So these are just use cases. With ChatGPT, we gave it an input, a prompt to generate a 100-word executive summary for a bridge construction report in La Pine, Niger State. We told it to include timeline, dates, budget estimates, and other relevant information. Because as engineers, this is what we do mostly when we are working. And so it developed an executive summary saying that the project will commence on March 1st to December 31st with a budget of about 2.5 billion. So this is just to show that, okay, in engineering operations as well, you can use these generative AI techniques to give you the kind of output that you want and make you more productive. This is an image generation with Meta, where we said generate an image of a reformed Minna city under the new Niger initiative. And you can see the image generated. Then you can also, of course, generate code. This is from Gemini, where we ask it to generate code for logistic regression classification. So it has done that. So based on this, you have a lot of applications of Gen AI in engineering. So if you look at agricultural engineering, you can design irrigation layouts, you can predict crop yield, you can generate pest control strategies, and you can manage greenhouses. In civil engineering, you can generate structural designs, you can simulate traffic flow. In chemical engineering, you can optimize reaction pathways. In electrical, you can design circuits, diagnose power faults. In mechanical engineering, you can design CAD models and so on. So depending on the aspect of engineering, you can use Gen AI to fit in, whether you're looking at the text, whether you're looking at the images, or you're looking at the code aspect, or even just workflows on how you can implement some of these technologies. So some of the opportunities that arise from these applications are, first, you have an enhanced design and prototyping. So it can accelerate the creation of these innovative design simulations, prototypes, and so on. So it will reduce the development time and also reduce the cost, because the longer something takes, the more you have to spend in terms of energy, in terms of resources, and so on. Then also it helps you make data-driven decisions, because the AI tools can analyze some complex data sets for you and tell you about patterns that are in the data, and that can help you take better decisions without you necessarily have to go through the data yourself. Then you can also automate a lot of repetitive tasks. So like coding, documentation. A lot of us don't like documenting, especially writing reports or proposals and so on. So this can automate some of these tasks for you so that you can focus on other aspects of your work. Then you can use it for personalized learning and skill development, because then you can teach people how to use these Gen AI techniques in engineering practices. You can teach them how to develop these Gen AI techniques for engineering practices. Then also it helps with collaboration and knowledge sharing through documentation, generating reports, and so on. However, there are also limitations and potential pitfalls when it comes to generative AI. The first is the accuracy and reliability. So the outputs may contain errors and inaccuracies. And these, especially in engineering tasks that are critical, you want to minimize the error as much as possible. So you need to always review the output you get from generative AI to make sure that it is error-free. Then there are also biases in the models because it's based on the data it's trained with. The output of the Gen AI or the performance of the Gen AI is dependent on the data it's trained with. So if you're looking at local context, for instance, Nigeria, then it might be difficult to capture some of these local contexts because maybe the Gen AI technique was not trained on enough data that represents that local context. Then over-reliance on AI is also another potential pitfall, because if you use a lot of these AI tools, then sometimes it diminishes the critical thinking abilities and makes you over-reliant on these technologies. And something that you could normally do on your own, you would always want to go back to AI to get it done. Then there are issues of data privacy and security risks, because if you're working with proprietary data or sensitive data, then introducing that to AI or exposing it to AI can pose an issue of confidentiality and ethics. Then resource intensity as well. Developing these AI technologies usually have high computational demand and costs associated with the AI models. And this could be difficult for some organizations or teams to afford. But based on these opportunities and pitfalls, what are the implications for engineers generally? It means that engineers would have to redefine their skill sets, moving from your traditional based engineering to an engineering skill that includes AI literacy, digital literacy, and how you can implement, use, and manage these AI tools. And there will be a shift in roles because instead of focusing on manual design, engineers might need to oversee AI-driven design processes or AI-driven processes in general. And there will be increased innovation as well, because the possibilities of, bringing up novelty with Gen AI are limitless. So it will lead to creation of solutions that previously might have seemed too complex or time consuming. And then engineers also would have to work with AI, so collaborative AI as co-creators, where you blend human efficiency with machine efficiency. And then ethical and regulatory challenges, where engineers will have to play a role in addressing these challenges and ensuring compliance. And they would have to be at the forefront of developing policy related to AI and how it interfaces with engineering generally. So, in summary, what is the call to action? What are we asking people to do? First, you need to embrace generative AI because it has come to stay. And because of that, you need to understand these technologies, use these technologies, adopt these technologies, and then you would be an authority and a powerful voice on how to make these technologies better for the society generally, not just the engineering community, but the overall society. And also, you would need to upskill continuously as an engineer. You need to stay ahead of the learning curve. You need to understand these technologies as they come, understand their capabilities, use them, and because of that, it would make you more productive and more efficient in many aspects. You need to experiment and innovate with these technologies, try a lot of things with them, find out which one works for you, which one makes you more productive, and which one is more suitable for your domain and your field. But more importantly, you also need to be ethical and responsible. You need to use it in a responsible way. You need to ensure transparency, fairness, and you also need to respect privacy. But finally, what you need to know is AI does not replace engineers. It does not replace your expertise. It does not replace your creativity. It does not replace your critical thinking. However, it's a powerful tool that enhances these capabilities. So it's meant to complement and augment human skills, which would enable engineers to achieve greater things in terms of innovation and efficiency. Thank you.